Hello everyone from Math 161. This short video lecture is on derivative relationships, a concept we've spoken of before. Context here is very similar, slightly more nuanced in the following way. Each of the problems before you exhibits some common derivative relationships, and each one of these three problems has the same kind of general pattern. The first one, antiderivative of 2x over x squared plus 7. Here, notice that there is a derivative relationship between the denominator and the numerator. If I take the derivative of the denom, I get an exact copy of the numerator. Likewise here, taking the derivative of this denominator produces the exact copy of what is present in the numerator, and likewise for this third problem. Therefore, each of these problems can be solved in the same way. In each of these problems, I can simply set u to be the denominator, compute my du. My du is going to be 2x dx, and so here this dx dx is precisely my du. So this problem gets replaced with du over u pattern. Moving on to the next problem. Once you realize this relationship between the numerator and the denominator, let u be the denom. U is equal to secant x plus 1. Then your du is going to be the derivative of secant, which is secant x tangent x. Now, typically you would write this as du dx is our derivative of u with respect to x, and then we multiply by this differential dx to extract an exact copy of what is present in the problem with what we have produced in our u substitution. Now you can replace the given problem as du over u. Likewise, in the last one, it may take some work to realize that the derivative of the denominator actually equals the numerator, but that is the content of each of these problems, is to figure out what is the derivative of what. So u equals to e to the x plus sine x produces du then as e to the x plus cosine x dx. And now we can substitute du for the e to the x plus cosine dx and rewrite this problem as du over u. So each of these problems, which might look different initially, all follow the same general pattern. And in each case, the antiderivative of du over u is always and forever ln absolute u plus c. So in each of these problems, we're going to see a natural log of u plus c. And of course, the u is different in each context, and that's the only thing that distinguishes one of these problems from the other. Now, we're going to proceed by modifying this slightly in a way that, so this last one should be e to the x plus sine x. We're going to proceed by modifying this slightly as follows. So first off, let's move this stuff up just a shade. Now, let's take the same set of problems and modify them just very slightly and see in what way are things this different And in what way are things the same? Okay, so once we copy the problems over, let's simply imagine we change the denominator. Instead of being an x squared plus 7, well, maybe it's an x squared plus 7 squared. And instead of this denominator being what it is, well, maybe it was a secant x plus 1 cubed. And lastly, what if this denominator was maybe e to the x plus sine x all raised to the fourth? I claim that there's a very similar kind of relationship to what we did first. Obviously, the same u substitution is going to work here. U is going to be x squared plus 7. You still, what was a du before is going to be your du afterwards, right? This was my du, this was my du before. This is going to be my du afterwards. It's the same substitution. And so when we move into this substitution, well, it's simply du on top over u squared. And it's up to you to realize that, that's the same thing as u to the negative 2 du. Likewise, down here, this problem, it's up to you to realize it's the same as du over u cubed, and likewise, du over u to the fourth. Then you simply can rewrite du over u cubed as u to the negative 3 du. And likewise, rewrite this as antiderivative of u to the negative 4 du. Each of these problems fall under this general power rule for antiderivatives. And so upstairs, right, we had something else. Upstairs we had the du over u equals to natural log absolute value. That was the pattern that related to all three of these problems above. Downstairs, it's all about the power rule. So it's a very small modification between one problem and the other, and that's one of the things that to keep in mind when you're working through these antiderivatives. Let's actually finish through all of these. Go back and add my c here, add my c here. Let's finish this last one. So we're kicking it up by 1 and divide by it. So u to the negative 1 over negative 1 plus c. And so if we flip the u, distribute the negative, this looks like negative 1 over x squared plus 7 plus c. So we flipped the u was u to the negative 1, and then it flipped to the denominator and has an exponent of 1, and then this negative came out in front. Likewise, on the second problem of this set, it's a u to the negative 3 integrates to u to the negative 2 over negative 2 plus c. And so this is simply negative 1/2, and that's coming from the negative 2, multiplied by 1 over the u squared, and the u was secant x plus 1. And we're adding c, and then finally we're kicking this up by 1 and dividing by it. So this leaves us with negative 1/3 all out in front of 1 over u cubed, and what was u in this context? E to the x plus sine. So e to the x plus sine x all cubed. Okay, so this set of little techniques can help you recognize some similarities between what might seem like very different kinds of problems. Okay, have a good day. And happy Tuesday.